So we're continuing on. With our lesson. I got my smartboard back, by the way. Yay? Yeah. All right. We're continuing on with our understanding of interest. Okay. And actually, we didn't. I just threw that name out there just now. We're actually talking about geometric and exponential progression. Okay. When I talk about a geometric sequence, I'm talking about a list of numbers, right? What is special about the list of numbers in a geometric sequence? If I got 1, 3, 9, 27, 81, comma, dot, dot, dot. What's special about that list of numbers? What do you mean by that, Sophie? When you say multiply by 3, I don't know what that means. Can you be more specific for me? So, in order to get the next term in the sequence, I have to take the previous term and multiply by 3. And I can infer that because, gentlemen, oh, sorry, you're talking math. To get the next number in every sequence, I had to take the 1, multiply by 3 to get 3. Take 3, multiply by 3 to get 9. Take 9, multiply by 3 to get 27, so on and so forth, right? But this only gets me a list of numbers, right? But we learned yesterday that when we do a curve, right, I get values in between 1 and 2, 2 and 3, 3 and 4, and so on, right? It builds me a curve, okay? Now, we're going to use this understanding to talk about things like bank interest and car loan interest and things like that, okay? So the first example that I have here, okay, we got a formula for you. Yay, right? There's a lot of moving parts in there, isn't there, Taylor? That's a hot mess, isn't it? Okay? My goal here is to try and unpack it a little bit to get you to understand the parts. Okay? To get you to What's that?
Do you want to sign me up for that?
Sign you up for what?
8% quarterly?
Oh, dude. 8%'s like...
I know.
That's huge now, right? That's huge. You get a bank account now, like a savings account, you're lucky to get a full percent nowadays, right? Banks make so much money on us. It's not even funny. It's not even funny. Anyhow, so first of all, I want to tell you what each of these letters means in this formula, okay? A. We really should have this written as A as a function of t. Gentlemen, over there, please. I know that's not math. I should really write the A like this. A is a function of t. Okay? What do you think my t is? Well, you don't even have to speculate. I tell you what it is right there. Right? It's time in number of years. Okay? And the A is the amount I have after t number of years. Okay? So, P stands for something that I call principal. Who knows what principal is? The initial amount. The amount I initially deposit into the bank account. Okay? R. What do you think R is? I mean, I know it says rate, annual interest rate.
Rate.
Okay. So what does that mean?
How much you're making per something.
How do I usually express interest rate? When they show you on the car commercial, they say financing for only this much.
1% percentage rate.
Yeah, they give you a percent, right? Do I put a percent in for R, do you think? If you guys remember back a couple of units, maybe in Mod 2, no, had to be Mod 1. We talked about percent. It's Latin, right? It meant per and cent means 100, which means I take that number. So if I got this 8% interest,
Here you go. Mr. Cook, I need to go wash my hands.
go for it. Go. Can you, what is that?
I don't know. It's like some really old crusty.
Is that what Jesse did?
Yeah, that's what Jesse did.
Okay, you go wash your hands. Jesse, take care of that garbage, please.
Sheesh.
What? What did I do? Take care of that. They didn't do anything.
So if I got 8%, did they say 8% interest? If they got 8% interest, the number I use in my equation is not 8. I take 8 and divide it by 100, and I use that number. Divide by 100, move the decimal point over to the left 2 spots. So I get 0.08, right? So this is going to be 0.08. That's very important to use or to make note of in our equations, okay? We're never using the percentage. We're using the decimal equivalent of that percentage. How you doing, man? You out of here? All right. Now, the n number, okay? When we talk about compounding, girls, when I say this is compounded quarterly, what, and that's right here in the problem, what does that mean?
Quarter of a year.
So how many times in a year? 4 times in a year, right? Now, that's what quarterly means. It means I do something 4 times every year. But what am I doing 4 times every year? You get a statement, yes. The bank does something else other than print out a sheet of paper. Before they print out the sheet of paper to send you the statement, they do some, yes, Zach?
Do the math.
They do the math. They do the math. If it's compounded quarterly, that means they do the math 4 times a year. Okay? So, if you get 8% annual interest rate, what does annual interest rate mean?
Yearly.
That means I get 8% back every year, right? But if I'm compounding quarterly, what that means is I'm figuring out how much interest you should get back once a quarter. Doesn't sound like it makes much difference if it's compounded annually or compounded quarterly. So what I'd like to do, Mr. Erickson's going to be mad at me, but what I'd like to do is like to keep the number simple. Let's say I got $1 and I'm putting it into a bank. What's my principal? $1. Good. We know what principal is. Now, I got 100% interest. 100% annual interest. So, what's my interest rate expressed as a decimal? 100% means divided by 100. So 100 divided by 100 is 1. Okay, so my R is 1. Okay? So, remember, it was 1 plus R, which in this case my R is 1, over, and then my N value is how many times I'm compounding. I want to first do 1 time a year, compounded annually. And then I raise this to the NT power, which is the number of times I'm compounding, which is 1, times the number of years, which is 1. And I ask you, how much money do I have after a year? So this looks complicated, but let's start simplifying. I'm going to leave this $1 here, and I got 1 plus, what's 1 over 1? 1, right? And then, what's 1 times 1? For the power up here. It's 1, right? Do I even need to write that power up there? No, I'll just leave it alone. Now, it looks a lot simpler, doesn't it? Let's simplify this further, Tabitha. Let's simplify this further. What can I do to simplify this further? 1 plus 1 is 2. Doesn't get much simpler than that, does it? So I'm taking my $1 and multiplying it by 2, right? So how much money do I have after a year? $2. Now, are you ever going to find a bank that offers you 100% interest rate?
Maybe.
Let me ask you this. Do you think it's a good thing if a bank offers you 100% interest rate?
For you.
It's really not good for you as a customer. Because if you have a bank willing to offer you 100% interest rate,
They're going to fail.
that means your economy's in the tank. This means effectively that the dollar you have today is worth half the amount Yeah, exactly. The reason a bank would be willing to offer this interest rate is because inflation is mad huge. And this has happened in history before. Matter of fact, you guys studied it in world history last year, I imagine. World history was last year?
Yeah.
What did you guys study? Crazy inflation.
Stock market crash.
It had to do with the stock market crash, but more specifically. After World War I and before World War II,
Roaring 20s.
the German economy. Inflation in the German economy leading up to the Nazi takeover of the German government was about 800%. So what that means is, if I had $800 right now, how much money would that? I can buy $800 worth of things right now, right? This is about, let's call this an $800 phone, right? I could buy this right now. In a year, that $800 I have might buy me this. That's a bad day, right? You don't want this from your bank account. You don't want that from your bank account. Okay? So, anyhow, I digress. This is annual compounding, right? Now, let's do semi-annual compounding. How many times would that be compounding in a year? Twice. So, let me ask you, am I going to give you all 100% twice in a year?
No, you're getting 50-50.
50-50, right. So let's do that. So I got $1, and 6 months from now, I'm going to give you 50% in addition to that, right? So, in 6 months, I got how much money?
A lot. 50 cents.
Not just 50 cents, but in addition to my dollar I started out with, right? I got $1.50. So plus 50 cents equals $1.50. So that's after 6 months, but I still got another 6 months of interest, right?
Yeah.
Now, I get my other 50% interest for that 6 months, right? What am I taking interest of? Am I taking the interest from the dollar? I'm taking it from the 150, right? So half of 150 I'm adding to it. I get another 75 cents. I get 225. Huh.
Be a millionaire in no time.
Compounding might be a good thing, but millionaire ain't what it used to be, right? Compounding might be a good thing for us. Okay? So, let's go back to the problem. Now, we got our $300. And I'm putting it in a Roth IRA when I'm 18 years old. God, that was a long time ago. It earns 8% interest compounded quarterly. We already figured out my N from this equation up here is 4, right, Trey? 4 quarterly means 4, right? All right. How much will your account be worth when you reach the age of 60?
$12.10.
From 18 to 60, it's going to be worth $12.10. Let's do the math. So, my amount at time t. First of all, how many years will that money have spent in that bank account?
42.
42. I like that number. So I'm looking to find A of 42, right? And that equals my $300. Oh, 3,000. That's a little better. 3,000 times the quantity, 1 plus, what's my rate? 8, but as a decimal. 0.08. What's my N value? Quarterly, so 4. To the N, which N again is 4. 4 times 42 power. So, that's a hot mess. Let's simplify. A of 42 equals 3,000. And what I'm going to do is I'm going to simplify this guy in parentheses, and I'm going to simplify the exponent outside the parentheses. So, 0.08 divided by 4 is going to be what? 0.02? And then plus 1? 1.02, right? And then the 4 times 42? 168, right? 4 times 40 is 160. 4 times 2 is 8. 168. Now, it's time for PEMDAS, brah, right? 1.02 to the 168 power. Can somebody rip that out for me? 27.85. Nice. So this equals 3,000 times the quantity, 27.85. So that 1.02 to the 168th power got me that 27.85. So how many times did my bank do math for my money during this period of time?
160.
Yeah, exactly. 4 times every year for 42 years. Nick's on point. So now all I do is the multiplication, right? Which that's just a shade under 90,000, right? What's that now?
83,550.
83,550. Okay. That is a lot of money just for putting $3,000 in the bank way back when, right? Imagine if you put, not $3,000, imagine if you put $200 in a bank account every month. Not a bank account, because bank accounts suck, right? Seriously, bank accounts are really awful. When I was a banker, I was giving out savings accounts with 0.01% interest. Yeah, that means if you had $100 in there, you'd get a penny of interest every 10 years. Ride that rocket, right? Ride that rocket. Yeah. And then you'll see a bank say, our interest rate is twice as good as anybody else's. Well, okay, 2%. Or 2 pennies every 10 years. Great. Yep. So, banks are trying to play you all the time. Don't get played. All right. Why is that like that? Okay, now. Why is that there? Now, when we did this little deal right over here on the paper that I said Mr. Erickson was going to be mad at me about, did we figure out that compounding was a good thing for me as a customer or a bad thing? A good thing, right? So banks, in order to compete for my money, are going to offer more and more compounding, right? So this bank was offering compounding twice a year. Could somebody do compounding monthly? Yeah. How many times would that be a year? 12 times. So my n value would be 12, right? Could I do it daily?
Yeah.
Dana, come to Q6 to the office, please. Dana, come to Q6 to the office.
Could I do it every hour
Yeah.
of every day? How about every second? I mean, we got computers now, right?
Yeah.
We got computers to do that stuff all the time. Now, let me ask you this. If I do it every millionth of a second, so every second I'm doing it 1,000,000 times, will that help me as a customer?
It could.
How much does it help? Is there a limit? Is there a limit? So say I'm compounding continuously. So I divide that 8% into an infinity number of chunks, right? And I do that calculation an infinity number of times every year.
To infinity and beyond.
Does it help me as a customer?
Sure.
It does, but there's a limit. And we've already talked about the number that's reached at this limit. The number is this guy. Where did we see this number before? Natural log. Natural log was 1. And we also did some exponent stuff with this guy, right? This is the number of natural growth. Okay? So, most banks don't compound quarterly. They don't compound monthly. They don't even compound daily. They compound continuously. Okay? And the number that they use to compound continuously is E. All right? So, we're going to do some E practice again. We're going to do some E practice. Evaluate these guys. E to the 4th power. Get practice on your calculators doing this. Sophomores, use your approved calculators. Juniors and seniors, I guess you can use your phones. Yes. Sophomores, use your approved calculators. Yours is improved and yours is mad. You need practice at that thing because I think you could probably do quite a bit of stuff with that. So, e to the 4th power. 54.598. I'll round to.
No. Gotta be exact.
Can I?
It says 4 decimal places.
5981 then?
Yeah.
Or 82?
5896.
Can I be exact by writing the number? Why? It continues forever. It never ends. It never repeats. This is a number that is irrational. Okay. E to the negative 3 power. E to the negative 3 power.
0.0498.
Okay. 0.0948. And lastly, square root of E. Does that say square root of E? Does it mean the same thing? Yeah, half power means square root, right? What is that, Jesse? That?
Yeah.
All right. All right, so we got our calculator practice in, right? Now, doesn't this equation look a lot easier than the previous equation? Looks a lot easier, right? If I want to find my amount at time t, I take my principal, I multiply it by e, and raise e to the what power? The r times t power. Do I like this equation better than the last equation? Yeah. So, you're going to see this equation a lot more. than you will the other ones. Not saying that they don't pop up, but the other equation is much more rare. All right, so $100. So $100 at an annual interest rate of 4.8%. When you see, very important, when you see this clause compounded continuously, when you see that clause, Nick, when you see compounded continuously, what do? You use PERT. PERT. Do you see it? PERT. Use PERT. When you see compounded continuously, you use PERT. When you see compounded quarterly, you gotta use old busted equation. When you see compounded continuously, when you see compounded, where did it go? When you see compounded continuously, you use the new hotness.
The new hot.
New hotness.
You know that PERT is a standard shift?
I do.
Yeah.
I do. It was quite popular when I was your age.
I used to use it.
A lot of people used to use PERT when I was your age. Anyhow, so it says, how much money will I have in the account after 3 years? So I'm trying to find my amount when time equals 3. We're almost done here. We're almost done here. I take my $100. I multiply it by E. What should I use for R?
Yes.
What should I use for R? Should I use 4.8?
No.
No. Why not?
0.048.
Why, Nick?
That's how percents work.
That's how percents do, right? So 0.048 times T, which is
Time in years.
3. Yeah, it's time in years, and it's saying after 3 years. Okay? So now I crunch the numbers. So do 0.048 times 3, that'd be what? 0.142? I'm doing this first, right? I think that's 0.142. Am I right? Or no, 1.44. Or 0.144. That's 144. So this is 100 times e to the 0.144. And e to the 0.144, we got a few seconds left here, Brandon. Oh, I guess we don't. But you want to learn, don't you? You got passing time. Do this. And then the exit ticket, due Monday. Exit ticket due Monday.